Hi, so in this quick video, I'd like to show you how we can use interactive notebooks remotely on the La Palma cluster to explore data, and especially here to have some benchmarks and analysis check on the Monte-Carlo production that we have analyzed with LST chain. So in a previous ASWG meeting, I showed how we can connect remotely to a cluster here La Palma, start a Jupyter notebook over there on the cluster and have it displayed on our own laptop. So I'm using a stackyter tool to do that. So this is what I will be using now. So with a single command here, I will be connecting to La Palma through SSH. So as you can see here, and what it's doing under the hood is connecting via SSH and starting a Jupyter notebook on the cluster. And it's sending back the link to me so I can display this notebook in my browser. So you see here, I've just clicked on the link and it's displayed in my browser. So I will go full window here. And once I've connected here, you can see I have a series of different notebooks that I will start. These notebooks present some dashboard, interactive dashboard to explore the different data that we have. So the first one I'd like to show you is a simple one showing some histograms of reconstructed parameters. So when I start this notebook, I can have some histograms for different data levels, so 1 or 2 of the reconstructed parameters. And when I start it, I have here a list of the different DL2 files that have been produced by LST chain. You can see here the different production that we have done all the time. So there is for each ID, the date, the version of LST chain, the version of the analysis or the small tag, and the file, the particle, sorry. So I can click on one of these ID, and it's then starting a window with some histograms of all the reconstructed parameters. So this way I can quickly have a look to all the reconstructed parameters at the different data levels, DL1 or DL2. So this is nice. I can quickly check my parameters and the histograms. But what is really interesting is that I can click on another production, of course, and have the new parameters displayed on top of it. So for example, I can take another production, still for the gamma file. And you can see here that we have the new histogram for all the parameters displayed on top of it. So this way I can quickly compare the different histogram between different production, different kind of settings, or different version of LST chain. In the present case, we have some small differences for some parameters because these two production analyzed with the last version of LST chain, version 0.5.1, are done with two different integrator. So the neighbor peak integrator or the global peak integrator. So thanks to this, I can quickly see if something is unusual or wrong in the new production that I've done or the new settings that I've tried. Okay, the second dashboard I want to show you is very similar, but it's for 2D histograms. So here again, I can choose a data level. So in LST chain up to now, we copy all the parameters that are at level 1, also at level 2. So if you take level 2, you actually have all the parameters. So here now I have also a list of all this production. So I will take the last one, for example. And what is starting now is a simple, a single window with a 2D histogram. And now what I can do is pick the different parameters that I want to display in this 2D histogram. So for example, I'd like to display the intensity as X and gamma s as a function of intensity. So here the plot is not so great because intensity is very large. So what I can do, for example, is use the log value of the intensity. Okay, great. So now I have something quite nice. I have the gamma s as a function of intensity. Sorry. I can, for example, change the beginning of my histogram. Has it changed? Okay, yes. And I can also use log normalization for the color representation. For some plots it's better. And once I have this histogram, so I can see already the evolution of the gamma s as a function of intensity, the gamma s, so of gamma particle increase with intensity. This is not very surprising. I can also add some statistic on this histogram. So for example, I can plot the mean of the gamma s as a function of the log of the intensity. So this is what I get here with 1 sigma deviation. So here again, I can use this tool to quickly explore a new prediction that I've done and see the evolution of some parameters as a function of others, and see if something is unusual. Okay, the next dashboard I'd like to show you for higher levels, so DL2 or DL3. So let's see DL2 first. So this is using Gamma board, which has been developed for the deep learning analysis, where we have done a lot of experiments. So we needed a kind of tool like that to quickly compare all the different experiments and production that we have done. So here I'm starting the tool, and here again you can see that I have all the different production done until now, for which we have DL2 files. But now we don't have any particle because we want to have metrics of higher level. So if I take the last production, what you will see here, it's loading the data. You will see different metrics that we can use at DL2 to check our results and our prediction. So I will have here the angular resolution, energy resolution, effective area, the ROC curve with the AUC, the precision as function of recall. It's also to check the classification power of our reconstruction. What I can do also here is to play a bit with the gamma s cut. So I want to increase this gamma s cut, for example, to 0.8 to see the evolution of the different metrics. You might have seen that the precision increased and recall decreased, and the angular resolution and energy resolution look already much better. So this is also quite interactive, so you can zoom on the different windows if the axes are not so great, like that, for example. And what you can do also here is to add some reference plots, so the CTA performances or requirements. So of course, these performance and requirements for the north are for the full array, for the port 3B. So you have to compare with a grain of salt with LST mono, of course, but it gives you a kind of reference to compare the DL2 reconstruction. Okay, for some reason here we don't have any information of these experiments, but usually you should have the different config, the config file that has been used for this production. All right, and finally, the last dashboard I want to show you is the DL3 one. So here we want to have the highest metrics, so the IRF. So this is what you can see already here, the angular resolution, energy resolution, effective area, and sensitivity. So the sensitivity and these different IRF have been computed to optimize the sensitivity in each energy beam by optimizing the gamma S cut in each energy beam. So here again, I have my list of production IDs. So let's compare, for example, the last 3 predictions that we have done with LST chain with the different integrators. So here you can see the different IRFs that we get, and I can plug the other ones on top of it. So this way I can quickly compare the different production and different settings. And in the present case, as you can see, the neighbor peak integrator seems to give better results both in sensitivity and resolution. Okay, so this was a short video. I hope I demonstrate to you how we can have some interactive notebooks and interactive dashboards remotely to keep track of the different production and compare them and compare the different settings of the different production to compare the results. And this way we can also keep track of the different changes in LST chain and how they impact the results at the end. So this is also, I wanted to show a kind of an expert mode, because the notebook here is fully open, so I can still develop and play also a bit more with the code if I want to add something or remove something. But we can also have a completely user-friendly approach where the notebook is displayed as a dashboard without any entry. So you will see only this window and the user cannot type anything. So to make sure that the user doesn't change anything and just quickly go through the data and explore the different predictions that we have done. Okay, thank you very much for your attention.